Okay, so today we are going to start talking about section 5.3 and we're going to start exploring the law of cosines. So we've been exploring how to find the missing sides of triangles. And last class we talked about how to use our right triangle ratios to find the missing sides in right triangles. So in typical trig notation, if you label the corners or the angles of your triangle with capital letters, then we label the opposite sides with their lowercase letters. So for example, we have angle A up here in the top, and lowercase a is labeled as the side across from it. Capital C is on the right angle, lowercase c is on the side opposite on the hypotenuse, and uppercase B as the angle, lowercase b side opposite. So that's our typical notation. And if we put values into this, so for example, if I label A as 3 and angle B as 40 degrees, I could easily ask you to solve for side C using your adjacent and hypotenuse ratio, so cosine. So we would say that the cosine of angle 40 or 40 degrees over 1 equals adjacent, which is 3 over the hypotenuse, which is C, which is what we're missing. We would cross multiply and get C times cosine of 40 degrees equals 3 times 1 or 3, dividing both sides by the cosine of 40 degrees. We get this ratio. So side C, or the hypotenuse of the triangle, is equal to 3 divided by cosine of 40. And if we are in degree mode on our calculator, when we go to type that in, we get that C is approximately 3.92. So solving right triangles with trig isn't that bad, but not all triangles are right triangles. So we might have triangles like example on the right hand side of your screen. So there are no right angles in this triangle, so we can't directly apply our SOHCAHTOA ratios to it because there's no hypotenuse since there's no right angle. But one way to fix that problem is we could, in theory, drop an altitude down or a height from the top corner of the triangle or from any corner of the triangle to the opposite side to form a right angle. And from there we could start applying our right triangle ratios. So what we're going to do now is we're going to look at how to develop a formula to help us solve for the missing side of any kind of triangle, not just right triangles. Okay, so all I've done is from the last slide I put that picture of the non-right triangle onto a coordinate graph. So what we have here is that point C is now the point 0, 0 because it's at the origin. Point B, since it's on the x-axis, has a y-coordinate of 0, and we've gone over a units across the bottom, so this is the point A0. And then we need to figure out how to label point x to give it a coordinate point. So what we're going to do is just like on the other picture, we're going to drop an altitude down, and we're going to label the height of the altitude as y, and the distance away from the origin as x, which is going to turn this point into the point x comma y. So we want to develop a formula to help us find any missing side. And what we're going to do, we're going to try to find the length of C using just sides A and B. So what we're going to need to use in order to do that is something called the distance formula, which you've learned about in geometry and algebra 2. So the distance formula is normally written as the distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. To make this formula a little easier to work with, though, we're going to square both sides to get rid of the square root. So this is going to become d squared, the distance squared, is equal to x2 minus x1 squared plus y2 minus y1 squared. And we are going to apply this formula to find the length of C. So we're going to let B be our x1, y1 point. We're going to let A be our x2, y2 point. And we're going to just substitute into this formula and see what happens. So we're finding the length of C, so C squared is going to equal x minus A squared, using our substitutions, plus y minus 0 squared, just using our x2, y2, x1, y1 as we've labeled them. Well, if we go ahead and simplify this, we're going to get that C squared is equal to x minus A squared plus y squared, because y minus 0 is just y, and y squared is just, well, it's y squared. So we're going to continue to simplify. So we're going to square out x minus a. So remember, this is the same thing as saying x minus a times x minus a. So if we FOIL, we do our first, outer, inner, last, and simplify, we're going to get that c squared is equal to x squared minus 2ax plus a squared, all plus y squared. So now our goal is to write a formula that just uses the original parts of the triangle. So just uses our angles A, B, and C and our sides little a, little b, and little c. So we need to get rid of the x and y's that are inside of our formula right now. So to do that, we're going to do some right triangle trig. So if we look at how we drew this altitude, we cut this big triangle ABC into two smaller triangles. And we're going to focus on the triangle over here on the left. So we're going to focus our attention on angle C right now since it's at the origin. So we're going to set up a sine and cosine ratio for angle C. So if we look at sine of angle C, we get that it's opposite over hypotenuse. Well, opposite angle C in the green right triangle is side y, and the hypotenuse is b. So if we multiply both sides of our ratio by b to get rid of the fraction, we're going to get that b times sine of C is equal to y. So now we have a substitution for letter y. If we do the same thing for cosine, we're going to get that the cosine of angle C is equal to adjacent, so a, over hypotenuse of b. Oh, I'm sorry, it's not a, it's x. Whoops, my bad. Okay, so then of course, just like last time, we multiply both sides by b to get rid of the fraction, and we're going to get that b cosine of C is equal to x. So we're going to go ahead and substitute in for those two things into our formula. So we're going to get that c squared is equal to b cosine of C squared minus 2a times b cosine of C plus a squared plus, subbing in for y, we get b sine of C all squared. And then we just have to go ahead and simplify. So squaring out our terms, we get c squared is equal to b squared cosine squared of angle C minus 2ab cosine of C plus a squared plus b squared sine squared of C. Now I'm going to do some grouping. So I notice that I have a b squared sine squared here and a b squared cosine squared here. So I'm going to put those together and factor out b squared. So I'm going to get that c squared is equal to b squared times cosine squared of angle C plus sine squared of angle C minus 2ab cosine of C plus a squared, bringing down the rest of our formula. So if you remember back in Unit 3 when we first started discussing the unit circle in trig, we learned that sine of C, or sine of an angle theta, squared plus cosine squared of an angle theta is always equal to 1. So if you ever see this expression exactly as is, sine squared plus cosine squared, we can replace it with a 1. So that's what we have right here. So cosine squared of C plus sine squared of C is really the value 1. So we're going to rewrite this as C squared is equal to B squared, because B squared times 1 is just B squared, plus A squared, just bringing that to the front of our formula, minus 2AB cosine of C. And that is the law of cosines. So what this formula tells us is that the side of a triangle squared is equal to the sum of the other two sides squared minus 2 times the product of those two sides times the cosine of the angle opposite the side. So we want to take note of the fact that this angle matches with this side. So using that idea, we can rearrange that formula to find any missing side of our triangle. So we're going to go ahead, and on the next slide we're going to write down all our formulas, and then we're going to show you how to use them with actual triangles. Okay, so we're just going to rewrite the formula that we just wrote down. So we had, our first version was c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So if you notice, whatever side is over here also has to match with the angle over here. So using that idea, we can just rotate through and change it to solve for any other side. So for instance, if we wanted to solve for side B, we would have b squared equals a squared plus c squared, just switching the b's and c's from the previous formula, minus 2ac times cosine of angle B. And then last one, we would switch, and if we wanted to solve for a, we just look at our original and we switch the a's and the c's, so we would get a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So as long as the side that's over by itself is equal to the angle that's in the cosine, you're good to go. So we're going to do an example and show you how it works. So we have this triangle ABC and we want to solve for the missing side. So we're going to go ahead and put our letters on. So since the 12 is across from A, this is little a. So C is across from the 14, so this is little c. And then the 43 is inside of angle B, and it's opposite the blank side, so our missing side is little b. So we're going to set up our formula, so we're going to plug into b squared is equal to a squared plus c squared minus 2ac times the cosine of big B, of angle B. So all we're going to do is substitute in for our values. So we don't know b squared, so we're going to leave it as b squared equals 12 squared plus 14 squared minus 2 times 12 times 14, all times the cosine of 43 degrees. So at this point, you can either type it in directly as you see it into your calculator, or you can simplify your numbers. So 12 squared is 144. 14 squared is 196. 2 times 12 times 14 is 336. Cosine of 43 degrees. Okay, now just be careful. When you combine your like terms now, the 144 and the 196 are not like terms to the 336 because the 336 is being multiplied by cosine. But we can combine the 144 plus 196 and get that is 340 minus 336 times the cosine of 43 degrees. So now we have to go to our calculator, so we're going to make sure that we are in degree mode first, and then just type 340 minus 336 cosine of 43 degrees. Hit enter, and we get that b squared is approximately 94.27. But we want to know just the value of b, so we're going to take the square root of both sides and find out that just b itself is equal to approximately 9.71 units. So our missing side of the triangle is 9.71. Okay, so here are your two OYO questions. So you want to write these two triangles down on your note sheet, and you want to find the missing side of each of them and round your final answer to the nearest hundredth. So use your formulas that you wrote down and use that last example to help you.